AP Acid-Base Equilibrium by Kyle Butler and Logan Regis. K value. Ka equals the concentration of hydrogen ions. Kb equals the concentration of hydroxide ions. Kw is the amount of ionization in water, basis for determining acidity and basicness. Formulas. For any acid-base conjugate, Kw equals Ka times Kb. So using that, we can determine that the Ka equals the Kw divided by the Kb, and the Kb equals the Kw divided by the Ka. Why it's used. K-value helps to determine whether a compound is a stronger base or acid.
Calculate the pH of a 0.1 molar solution of methylamine, which has a Kb of 4.38 times 10 to the negative fourth. So our equation is CH3NH2 plus H2O yields CH3NH3 plus OH minus. Alright, so the Kb, to find the Kb, Kb equals your acid ion, your conjugate acid ion, plus your conjugate base ion over your acid. So it would be CH3NH3 plus times OH minus over CH3NH2. Then we have to do a Rice table. So you're only going to you won't use H2O because it's a pure liquid. So you'll only use methylamine, the methylamine ion, and your hydroxide ion. And we already know that methylamine is 0.1 molar. And then the other ions are 0. So you'd subtract X from the methylamine and add X to the two ions. So you'd get 0.1 minus X, and then you get X for the ions. And since the X is going to be less than 5% of your molarity, then you can just say that it's about 0.10 molar. So you have to do 4.38 times 10 to the negative fourth, which would equal X squared over 0.1 molar. And then you do OH minus equals 0.0066 molar. What just happened?
Oh, I just went back.
Oh.
That's slow.
Right. And then you get Kw equals your hydroxide ion times your H3O plus ion equals 1.10 to the negative 14th. And then you would write your equation as H3O plus equals Kw over OH minus, which equals 1 times 10 to the negative 14th over 0.0066. And that equals 1.52 times 10 to the negative 12th molar. And then you'd have to find the negative log of that. So you do negative log times 1.52 times 10 to the negative 12th, which equals 11.82, and that's your pH. Here we have 50 milliliters of water and our acid, and what we have to do is pour one sample into the water. Do that, and we have to stir it around once it's nice and stirred. Alright, it's all stirred and mixed in. So now we pour approximately 25 milliliters into our graduated cylinder. Oh, a little over. Going too under. It's hard. Alright, perfect. Now, step 5 into an Erlenmeyer flask. So we gotta put it in the Erlenmeyer flask. Alright, and then add 3 drops of phenolphthalein solution to the acid in the Erlenmeyer flask. 1, 2, 3. Alright. And using a barrel type pipette, add sodium hydroxide solution dropwise to the flask. Gently swirl the flask while adding the sodium hydroxide solution. Alright, now we're going to start to drop in the NaOH and wait for it to turn pink. We're going to stir the whole time too. You gotta make it go really slow.
You're close. I think this is it.
So one more drop.
Yeah, it's gonna keep coming out right. Oh, it is. Alright. I just put right around 5. Post-lab question. Average the pH readings for each trial to calculate the average pKa value for the unknown weak acid. So we get 5, that was our first trial, plus 5.2, that was our second trial, divided by 2. And the average pH is 5.1. Since we were at equilibrium, that's also the pKa. Question number 2. Identify, so we pretty much have to find the pKa of each of these substances. So we take the negative log of the Ka. First one is 7.2. Next one is 2. Then we have 5.4. Then take the negative log of this one, and we get 4.2. And then finally, take the negative log of this one, and it is going to come out as 3.5. Okay. Post-lab question number 3. Compare the experimental pKa value for each unknown with the literature values reported in question 2. Determine the probable identity of your acid. So our pKa was 5.1, so the closest to that was the potassium hydrogen phthalate, which is KHCA-H4O4. And then we're going to find the percent error that we got. So we take the actual minus experimental over the actual, multiplied by 100, and we got a percent error of 3.7%.